This is a screencast of the lecture given for Discovery-Based Laboratory 2 on April 10th on bioethics, specifically related to animal work and data reporting. In today's lecture, we're going to talk about the assignments, and I'll give you an overview of what's coming up for the rest of the semester. We're in the final weeks, so there's a bit of a crunch in terms of the poster and also finals week, but we'll review that in just a moment. We're going to talk about what's happening in the lab and what we've covered so far very briefly. And we'll go on to talk about bioethics and data reporting. Today's assignment on Canvas was a data analysis set. It was an Excel file that you should have uploaded as an Excel file. There were a couple of corrupted files, so please check your grades. If you received a 0 and you uploaded something, I put a note on there saying to please email your assignment to me again. There won't be a late deduction if the file was corrupted. Your introduction draft was also due. We anticipate getting all of the edits back to you by the end of the day on Monday on both the methods and the introductions for your posters, so you can put those together. The midterm exam is next Wednesday, April 17th at 12 p.m. for the main section. For the post-baccalaureate section, it'll be on Thursday, April 18th at 11 a.m. The main sections that usually take place on Wednesday at noon will be split into 2 rooms, and those rooms will be posted on Canvas, I think on Monday, as soon as we get confirmation from central scheduling. The final poster file, if you want us to print that for you, will be due on April 18th at midnight. In reality, I won't be getting to those files until first thing in the morning on Friday, so if you're absolutely not able to get it at midnight for whatever reason, just send it by email. You can print it yourself as long as you have a poster by the poster symposium, which will be on Wednesday, April 24th at 5 p.m. Also, if you can please check Canvas, there's an announcement about your vials. The vials all look fantastic. There is one group that doesn't have larvae yet, but you'll be getting larvae by Monday. For anyone whose larvae are not developing as quickly as you might expect, we're going to be working with you to put together a supplement so that you'll be able to report your data at the poster session, but those data might not necessarily be on your poster, and that's completely fine. We'll address those issues as they come up. In lab, during the break, you'll recall that we were collecting embryos for you, and those were allowed to develop to 3rd instar. This week and last week, we were collecting 3rd instar for you and putting them into the vials that you were setting up. This week, we anticipate that you will be marking larvae for GFP negative. And remember, the GFP negative larvae are the ones that are double mutants for the grapes gene. Next week, we anticipate that most of the larvae that went into vials on April 4th and April 5th will be a closing, so keep a close eye on your vials for flies coming out of their pupal cases. In the next week, we're hoping that you'll be getting your posters together. At this point, you should have your hypothesis, methods, and introduction drafted, and you'll be getting results this week, so you'll be filling in those sections, and we'll help you with that. Okay, so let's talk about bioethics. We're going to go through some regulatory issues first, and then we're going to talk about what regulations are in place to protect both people and animals from possible misconduct. And then we're going to briefly review data reporting and ethics related to that, and what happens when there's ethical misconduct in publications. So we do have a number of regulations that are aimed at making sure that experiments are performed in an ethical manner that protects the subjects as well as the integrity of the data. And the regulations are also in place to make sure that data are shared appropriately in publications. Why do we need this? Well, there are a number of important examples of research misconduct that you should be aware of. There are lots of great resources online if you're interested in this issue, and I think there's an extra reading in the optional reading section on Canvas if you want to read more about both academic and research misconduct. A really famous and important example is the Tuskegee syphilis study. This was a study that was performed as early as the 1920s and went on until the mid 1970s. This was a study that was conducted by the government to find out how syphilis progresses in humans. Um, the population that was studied was composed of Black male sharecroppers. This is a vulnerable population of people. They were told that they would be coming in and receiving medical care for their syphilis infection. There was a good treatment for syphilis at the time, penicillin, but these men, many of them did not receive penicillin. It was intentionally withheld so that the researchers could study the progression of the disease in these people. Interestingly, there's a misconception among especially young people, I would say even the public at large, that when you are on antibiotics, you can't drink alcohol. And that misconception stems from the Tuskegee syphilis study. So there is one class of antibiotic that you should not take when you're, or you shouldn't drink alcohol while you're taking this antibiotic, but the vast majority of commonly prescribed antibiotics, you can drink alcohol when you're on them. This idea comes from the Tuskegee syphilis study because the doctors who were conducting the study were telling the subjects that they should not drink alcohol while they're in the study because the alcohol would interfere with the treatment required for syphilis. In reality, what they were worried about was the promiscuity, the sexual promiscuity that often accompanies alcohol intake. And it would confound their study if their subjects acquired new sexually transmitted diseases. So they decided to tell the subjects that you may not drink alcohol when you're taking antibiotics because it interferes with their effectiveness. But in most cases, this isn't true. The government has also performed many other experiments, mostly in the 60s and 70s, related to exposure to nerve gas, to radiation, also exposure to hallucinatory drugs like LSD. Another example that you may be familiar with was conducted in the early 1970s by Philip Zimbardo. He was a professor at Stanford University who teaches in the psychology department. And what he was interested in is the idea, the psychological impact of someone being in a position of power versus someone who's vulnerable. And to him, the prison situation was the ideal situation. So what he did was, I think he planned on doing this for a couple of months, where he split up volunteers from his class into roles that were either the prison guards or the prisoners. And what resulted was a really complicated situation where the guards basically were abusing their power, and the prisoners were attempting to revolt but were humiliated. And there's some debate about whether they were beaten. But the experiment had to be canceled within 6 days because the students were basically experiencing psychological stress. Both Tuskegee and the Stanford prison experiment really raised a lot of questions about what kind of ethics are in place when you're performing research not only on human subjects, but also on animals. We're going to focus on animals, but I'm bringing up these human experiments so that you think about, or if you're interested, you can look up what kind of requirements are in place to protect humans who are in clinical trials. Because we talked about this last week, it's important to note, and we did talk about this briefly in class, that people who are volunteering, especially for phase 1 and even phase 2, are considered vulnerable populations. In phase 1 of clinical trials, the people who are volunteering to test that medication are generally younger people, college students, and also people who are at an economic disadvantage. In other words, people who would put themselves at risk to take a medication. And remember also that phase 1 is intended to figure out toxicity levels in humans. So they're really pushing those medications to the highest dose that they can. We're going to focus now on animals because our work uses animals. I think that it's really important that we think about what that means. I'm not sure that there are very many other settings where students are being so strongly encouraged to engage in research but receive so little in the way of training in bioethics, and also really being encouraged to think about what it means to work with animals. So I thought it might be useful to just consider some of the issues from the perspective of someone who's in favor or at least supports animal research, and from the perspective of someone who is not supportive of animal research. So on one end of the spectrum are proponents of animal research, people who are supporters. They would argue that animals are the only way that you can get information about diseases or about drugs because testing on humans is unethical. They would argue that many improvements in human health and even animal health and veterinary care have been made possible by the use of animals. People who are proponents would also say that research animals are well cared for. They have a veterinarian, they are cared for day to day, they receive food and water, they're treated when they have problems. And finally, another thing that they might say is that there is no alternative, that you can't ever really capture the complexity of a living organism using a computer, that you would have to use an animal to capture effects of drugs, for example. People who are opposed to animal research on the other side of the spectrum would say that regardless of the benefits to human health or even to animals themselves, it's unethical to use animals because animals don't have the ability to choose whether they're in a study or not. They would also say that human health has improved vastly just from washing hands and having toilets. So not walking through human feces in a field has improved health in this country to a large degree. They would argue that animals that are living in an animal facility and used for research are not good models of human disease because they're so stressed. They would say that humans who are extremely stressed are not doing well in terms of their disease, that the lower the stress level, the better the disease prognosis is. So if you have very stressed animals, they're actually bad models of human disease. And taking that one step farther, they would say that living inside a plastic box, regardless of getting food and water, is an impoverished life, that it's not fair to the animals. They would also argue that research can be done in computers and that many organ systems can be modeled using computer systems. So I present these two opposing views to give you a sense of the things that you should be thinking about when you're choosing to work with animals in a lab. Research can be done without animals. If you're interested in a research career, it certainly can be done without using animals in research. You may fall anywhere in between these two ends, or very strongly on one end or another, and just know that all of those opinions are valid and completely fine. You can still have a really good research career and never work on animals at all. I wanted to share this with you because I think people have a misconception about, one, the number of animals that are used and the fates of the animals that are used in research. This is now a slightly dated reference, but you can see the trend is fairly stable over the past 10 years or so. About a million animals are used each year in the United States. It's important to note that when I say used, the animals are used for the research, and then the vast majority of them die. It's extremely rare to have research animals be adopted out or sent to a zoo or a farm. I think a lot of people have a misconception that animals that are used for research that doesn't require the death of the animal survive. But even when it's dermatology research, the animals are ultimately killed in the research facility humanely. And we'll talk about that in a little bit, about the regulations to do with working with animals. Now, here you can see that the majority of the animals used are not primates, they're not dogs. They're mostly, in fact, rodents, fish, and birds. So the minority of animals used are outside of those categories. Now, one thing that's come up a couple of times this semester already is treatment of the flies. So, by university standards, the flies are not animals. They're not regulated for research in the same way as mice, rats, dogs, pigs would be regulated, um, for, simply for the fact that they don't have vertebra. One thing that we do think about, though, and this is something that we're asked to consider when we're making regulations related to lower organisms like worms or flies, is, do they feel pain? Well, I can tell you that they have pain receptors on neurons that are the same as ours. So the channels, the receptors, the transmission of what we call pain signals is identical in people and flies. The thing that gets really complicating is when you start thinking about what pain is. So you might not have that much of an emotional response to the flies feeling pain because they're not writhing on the floor. Do they feel pain? Yes. Do they feel discomfort? I don't know. We don't recognize flies as having a relatable emotional response to pain. So it's very difficult for us to ethically consider flies in the same way as we do dogs, because dogs cry when they're in pain. So lower invertebrates are not regulated like vertebrates, but you should think about what pain means. So we are not allowed to pull wings off or in any way torture the flies. The methods of killing the flies and larvae are dictated by the university. We can spray them with alcohol, we can crush them on the counter, we can put them in the freezer, we can also put them in the refrigerator. We're not allowed to put them down the drain or throw them in the trash, but we can autoclave them. So just know that those choices were not made by our lab, but they're made at the level of the university and even at the level of the government, which we'll talk about in just a minute. So what are the regulations that are in place regulating research? There are many, many different levels. It starts at the federal level, where the National Institutes of Health uses also the USDA animal welfare regulations to determine whether research is fundable. And once the research is funded, those funding sources require that you comply with the rules that are set out by the Public Health Service. So the rules are really generated at the level of the government. The funding agencies refer to them and require that anyone receiving funding complies with those rules. At the level of the university is aware of all research funding coming in and funding sources. There's an institutional officer that oversees all of the research and also oversees a committee called the Institutional Animal Care and Use Committee. This is called the IACUC. It is composed of a number of faculty members from different departments and also a veterinarian. So anytime you propose research in a university or at a pharmaceutical company, anywhere in the United States, there is an IACUC in place at that agency, whether it's a university or a pharmaceutical company, and they review and approve all methods used when managing animals. And that spans from housing to methods of euthanasia to treating issues as they come up and what you're actually allowed to do to those animals. The number of animals is also regulated. You can't just order 100 rats you need to statistically justify how many animals you need. That's usually done using a statistical power analysis where you have preliminary data and you use that preliminary data to estimate how many animals you need to see a difference between two treatment groups at some specified statistical significance. You can see here in this image, this is actually a mouse facility. And these animals are in what's called a barrier facility where these racks have their own air supply and they're HEPA filtered. The person and anyone who walks into this facility has to be completely protected, not so that they're not infected by the animals, but so that the people don't affect the animals themselves. So the animals are living in a sterile environment. This is the size of a cage that mice live in a lab. This is dictated by the government. And usually you can keep between 4 and 5 mice in this cage. They have food and they have water that is changed usually twice a week. So how do these bioethics in dealing with animals extend to data reporting? For your own work, you should be aware of how you should be collecting data and reporting it. Under no circumstances are we going to eliminate any data. The reason for that is we have designed our experiments very carefully. Your approach is sound, and you won't have the statistical power in terms of numbers and repeated experiments to eliminate anything statistically or objectively. You can, if you're doing a very large study, analyze the data using statistics and determine outliers, things that statistically, mathematically imply that something was done wrong and that data point or data set should not be included when you're reporting your final data. Data itself should always be obtained with thoughtful planning, and that's why we perform hypothesis-driven experiments that aim to use very simple methods to answer simple experimental questions. Anytime you're reporting data, you need to be very, very clear about how you determined, in our case, how something worked. So we're going to be talking about that next week in lab. How do you use statistics to say that your compound is potentially useful as a chemotherapy or potentially useful as a radioprotector? In any case, when you're performing experiments, experiments without exception are expensive, and I would argue without exception paid for by someone else. So you have a responsibility to share that data in an ethical manner. When you report your data, you should be aware that there are specific relationships among the researchers who performed the research. So nobody performs research in a bubble. I think we'd be really hard pressed to find any research article with only one author on them. So it's important, even in your own work in Discovery Lab, that you give credit to anyone who contributed to the data that you're reporting. In other words, if you were given a compound by a lab, we need to credit that lab because the research would not be possible without that other lab donating the materials to you. The other thing that's very important to acknowledge is funding sources. So in our case, the Howard Hughes Medical Institute provided a great deal of funding. They were part of the $1.5 million grant that got our lab started. We had half of that, so $750,000 that went to renovating our lab space, which was a very large storage room before we were in there. Also purchasing every bit of equipment that's in the lab, and the ongoing support of supplies for 5 years, which is now ending, and now the molecular, cellular, and developmental biology department is supporting our class. So I'll be sharing with you a list of people who gave money, and also we should be acknowledging Tintin Su's lab, who provided us with the resources, who provided us with the means to do the experiment, for example, letting us use their radiation machine. On your posters, you're also going to have a list of authors. Generally speaking, when you have authors on a paper, you should be including anyone who contributed intellectually to your project. In a real lab, that might be the TAs. So perhaps the TAs gave you information and helped guide the design of your experiments, and you might be able to justify including a TA on your poster. Of Discovery Lab and for the Cure Symposium, you will only include authors who were in your group. So you might have 2, 3, or 4 authors on your poster only. And if you wish, you can acknowledge your TAs. This is the paper that you read as part of the experimental design and Sioux Lab research module. You can see here that there are 6 authors listed. Anthony Edwards is listed first. He was an undergraduate in the lab who did an honors thesis, and his work focused on a piece of a project that belonged to a postdoc named Mara Gladstone. Mara was a postdoc, as I said, and her work was based on the drug screens that we perform in our lab. Tintin Sue is listed last because she's the principal investigator in the lab. In the biological sciences or the life sciences, the principal investigator is always listed last. The people in the middle are people who also contributed intellectually to the project but had a much less important role to the work. Generally, the first and second author, as well as the last author, are the most important people on the paper. This is where the currency comes in for publications. In the life sciences, your impact as an author is determined by how many papers you have as last author, first author, and second author. Now, this paper is a bit unusual in the sense that it's likely that when Tintin and the group of researchers got together to put together the author list, they couldn't decide who contributed more, Anthony or Mara. So it's also somewhat commonly done in this case, where if they really hit a point where they can't decide, they give co-first authorship. So you can see there's an asterisk here indicating that both Anthony and Mara contributed equally to this paper, and that's indicated here. The middle authors sometimes are listed in order of contribution, and that seems to be the case here. They also can be listed in order of the alphabet, because these middle authors, if you're a middle author, it doesn't really matter if you're third or 103rd. It all sort of contributes the same to the impact of your work. Now, a question that comes up frequently is what happens if somebody is caught lying? We assume that research is done ethically and that it's reported in an ethical manner, honestly, but it is true that many articles are published and then found to be untrue in some way. It's estimated now that about 1 in 100 papers are not reproducible or contain some ethical misconduct that can include fabrication or just making up data, duplication, or plagiarism. Now, duplication and plagiarism are a little bit fluid in the sense that if you duplicate data from one of your own publications, that is unethical, because somebody seeing your most recent submission might say, wow, look at this incredible body of work. But really what you're doing is just reproducing information that was already reviewed and published in a different publication. And that is not okay. If you witness any research misconduct at all, even in Discovery Lab, you must report it. I think the reputation of science really relies on all of us keeping each other in check and making sure that everything is done properly. What happens if someone's caught? So the most common thing that happens right off the bat is that the paper is retracted. Unfortunately, now that things are published online, papers can still circulate without people understanding that papers were retracted. A great example of that is the autism study that was related to vaccines. That paper was retracted and should never be referenced as a scientific article, but keeps coming up again and again and gets circulated as a publication. If there is some research misconduct, it can result in loss of a research position. It can result in lawsuits by participants, though this is very rare. It can also result in repayment to funding sources, which usually is at the university level. So the personal consequences of fraud are not going to jail. People ask that a lot. Do the scientists go to jail? They do not. I think in the worst case, they lose their medical license or they lose their position, but that also is extremely rare. So let's talk about the Cure Symposium in a little bit more detail. You will be preparing in the next week or so a scientific poster. Now, I'm showing you this one because I think it's a reasonable example of a poster that visually is well balanced. I think that it looks fairly easy to present. I like the data, and we'll go through each of these sections to see why this is. The scientific poster is something that is used in all fields in one way or another. Just as a reminder, the Cure Symposium is on Wednesday, April 24th at 5:30 p.m. These are pictures from the Cure Symposium from previous semesters. You'll see here that there is food, so I would encourage you as soon as you get there to eat. It's not intended to be a dinner, but there's usually enough where people can, fill up and be okay until 8:30. This student here is presenting, and you can see that there's a fairly large crowd around her. You may have anywhere from 0 to 15 people coming to your poster, and we'll talk about how to deal with that after the posters are submitted. If you're wondering why we do this, I wanted to point out that this is a really common format for presenting research. This is an image from the Society for Neuroscience conference that's held every year in Washington, D.C. It's attended by 30,000 people, and there are poster sessions every afternoon for many, many hours. So it's a little bit challenging to navigate, but I think it's important to understand how to present a poster if you end up in this setting. So here I'm going to provide some advice on scientific writing and presenting data on a poster. The introduction, you've already submitted a draft of that, and the things that I'm going to be keeping an eye on are mainly efficiency and simplicity. So the best kind of scientific writing really has to do with taking a very complicated subject matter and making the presentation very easy to relate to and easy to understand. This is a real skill. So mainly what I'm going to be doing with your introductions is reducing the amount of text quite a lot. So, flowery writing, really descriptive writing isn't appropriate in this setting. The writing itself should reduce all filler words if possible and take what you've done and basically cut it in half. My rule for scientific writing is write it all out, and then after it's written, cut it in half and then cut it in half again. Usually there are word limits, and you'll be facing that with your specific aims page, making it challenging to get what you need to say into a small amount of space. And this is really good practice. There's an example here that you can read when you have some time. Something that I highly recommend is The Elements of Style by Strunk and White. I got this when I was in college, and I love this book. It's a really small manual. I'm sure it's available online. I like my paper copy, and it will teach you every single rule from when to use the comma to which is the right word to use, which or that. The methods section shouldn't be very long, and I would highly encourage you to put an image in there. Put an image or two that will help you present your poster. So something that reminds you of the important points. In this example, it's a poster about salmonella, and this person felt very strongly that the most important thing with regard to their research was the fact that salmonella poisoning is very prevalent, and there are a lot of deaths per year worldwide. So they used this image to talk about the centers for issues with salmonella, and also to point out that these infections occur in the United States. The methods section we've talked about in a fair amount of detail in lab, and I also have your drafts, which are looking really, really good. The main thing with the methods section is, again, to be really, really efficient. Take out all unnecessary words and make sure that you have enough information for someone to understand what you did. Mainly, what did you test? What were the concentrations? What were your controls? And how did you do the experiment? It doesn't need to be a methods section of a paper. It can be much shorter than that, because remember, the poster is just a tool for you to present the information also orally. One important aspect that you should have on your poster is the sources of your of your compounds, and that would be the company, in this case Sigma Aldrich, and the city and state from which it came. Also, passive tense. This is something that doesn't sit very well with people because we've been taught forever that passive tense is not okay, but science is written in passive tense. If you have questions about this, I can help you with it. Just write in a way that's very easy to present. Images are good. This is an example from last semester when we were doing salmonella. The experiment was very complicated, and having an image with some simplified text will be very, very useful. Also, just a simple list with bolded words that will help you stay on track. Because what's going to happen is you'll be presenting, people are going to interrupt you. As you're presenting to one person, 12 people are suddenly going to show up. So you have to remember where you were on the poster so that you can loop back to the beginning to present to the people who arrived midway through. The results section should be very efficient as well and use graphs whenever possible. So you'll want to have figure legends so that if you have to step away from your poster, someone will understand what you're showing. But try to be efficient in the sense that if you have triplicates, average them. And if you have multiple experiments performed, try to pool them together if the experiment is simply repeating what was done the previous week. This is a poor example of presentation. These people did a number of experiments that are basically reproductions of each other. They should have pooled these together. These people did this exact same number of experiments and are showing it really efficiently here. And you can imagine that this is going to be a lot easier to present than this. The poster itself should be visually interesting, so not loaded with text. It should have images that will balance it, avoid clutter whenever possible, and keep in mind that you are the presenter. This is something that people often forget. There's nothing, I think, more irritating to someone who's listening to a science presentation than when you simply read the presentation or the poster to the person. It's not easy to listen to. It's a little bit insulting to people because you can read. So make sure that your presence is enhancing what you're showing on the poster itself. So just to summarize, be efficient, be very clear, and make sure that your poster is visually interesting to look at. So today we talked about what's been happening in the lab. We went through some bioethics specifically related to animal work, and also data reporting, and went through the various sections of the poster. Do refer to the Cure Symposium poster guide. That will become the rubric for grading, and there's a nice checklist for you on the back page, similar to what you got for your proposals.